is the little first blank here. So two events are independent if the occurrence of one doesn't in any way affect the other. All right, so independent events, one does not affect the other. All right, two events are going to be dependent if one of them happening does somehow affect the other one happening, or affects the probability or the likelihood the other one will happen. So we're going to read through a couple examples here, and we're just going to say whether they're independent or dependent, and I'm just going to put like an I for independent or a D for dependent, so I don't have to write the whole word out. Okay, so just think about, does one affect the other? If they don't, then it's independent. If one would affect the other, then it's dependent. So the first little example just says flip heads on one coin and a tails on another coin. Do those affect each other? No, they're two totally separate coins, right? So this would just be independent. They don't, if that's just a bad example for dependent. So independent is two different coins, one doesn't affect the other. Okay, now this says a blue marble is chosen from a bag and set aside. It says then a green marble is chosen from the same bag. Would the first thing somehow affect the second thing? Yes. Okay, so anytime, a really good way to kind of define whether it's independent or dependent, if you have some kind of, we're drawing something or we're pulling something out of a bag and you hold on to it or you don't replace it, you keep it out, it affects the probability of the second thing because you don't have, in this case, we wouldn't have as many marbles in the bag. So you got to think about that. So that's dependent. Okay, you roll a 5 on a die, so like roll dice, roll a 5 and spin a blue on a spinner. Would those affect each other? Two totally separate things. This would be independent. Okay, now, probability independent events. So these two things don't affect each other. If you have A and you want two different things to both of these things to happen. If you see an and, you're going to want to think multiply. So independent events don't affect each other. Probability of A happening and B happening would be probability of A, whatever that event is, times the probability of B. Bless you. All right, so when you multiply these guys, remember they're either decimals or fractions. You do not need a, oh, I don't know what I just did there, but you do not need any kind of a common denominator if we use a fraction here. All right, so my little example, this says we have bag A and bag B. So I'm just going to kind of write this out so maybe you can see it a little bit better. So bag A has 9 red marbles and 3 green marbles. How many total marbles are in that bag? 12. It's okay to talk. All right. That was frightening. All right, now we have bag B, so this is a separate bag. And it says bag B has 9 black marbles and 6 orange. So how many total marbles do you have in the second bag? 15, right? 6 and 9. Okay, these are independent because you have two separate bags. We're going to draw a marble from each independent. All right, so it says find the probability of selecting one green one from bag A and one black one from bag B. All right, so don't worry about reducing fractions or anything for the moment. What's the probability I would draw a green marble out of this first bag? If I have 9 red, 3 green, if I just draw a marble, what's the probability I'd grab a green one? 3 out of 12. All right, you guys, I know it's early in the morning. Okay, 3 out of 12, don't worry about reduce for a second. Okay, now, what is the probability that I would draw, what does this say? A black one from bag B. 9 out of 15. And then all you're going to do is multiply these guys together to get your total probability. So you can reduce the fractions or you can just use your calculator. It's completely up to you, whatever you're more comfortable with. I'm just going to be lazy and use my calculator here this morning. So this would be 0.15, and it doesn't specify how they want us to write the probability. So just in case, 0.15, that would be as a decimal. If they want it as a reduced fraction, you can just convert it, do that math, enter, convert it real quick. This is the same thing as 3/20. So it's kind of a mix on the homework assignment how they ask you to write the answer. So just so you can write both. All right, now here is my second question. 2 seniors, one from each of 2 government classes, are going to be randomly selected to travel to Washington, D.C. And it says Wes is in a class that has 18 people and Emma's in a different class that has 20. What is the probability I would pick both of these people? So I have 2 totally separate classes. We're going to pick one person from each of the classes. If you're reading that, like, what's the probability I would pick Wes out of the first class? 1 out of 18, right? It says there's 18 kids in his class. He's one person out of that. What's the probability I pick Emma out of the second class? 1 out of 20. She's got 20 people in her class. So very, very, very small fractions here, but I'm just going to use my calculator. So 1 out of 18, and you just multiply these together. The probability I pick both of these people, let me go ahead and write that as a decimal. So I'm going to go 3 places here, because that's typically what they ask for on the Math Excel if you're doing that. So super, super tiny. If you think about that, if I converted that to a percent real quick, not even 1%, it would be a 0.3% chance that those 2 people would go on the trip together. If I converted that to a fraction, it's 1 out of 360. So it's a very, very, very small chance those 2 specific people would be chosen to go on that trip. Does anybody have a question at the moment? Okay, now if you have dependent events, I'm going to alter that little formula I gave you just a second ago just a tiny bit. It's very similar. It's still multiply. This is probability of A and B if one somehow affects the other. So it's going to be the probability of A, then you're going to multiply that by the probability of B, assuming that A happened. Whatever the first event they list is, you're going to assume that happened, and then what would the probability of the second event be if the first event did happen? Okay, so we've got another little teeny tiny example. So this says in a jar, you have 8 purple marbles, 10 yellow marbles, and 12 pink marbles. Now, before I even read the question, I'm just going to add up the number of marbles that are in this jar. So you got 8, 10, and 12, so what do we got? 30, yeah, that's a nice number. So there's 30 marbles in this jar. Okay, now here's what I'm going to calculate. These are going to be dependent, so one of them is going to affect the other. All right, if you take a marble from the jar and keep it, that's going to let me know if I hold it out, I'm changing the number of marbles in the jar. So if I hold it out, that automatically is going to make it a dependent situation. So I take a marble out, then your friend comes and takes a marble after you. What's the probability? You choose a purple, and then your friend chooses a yellow. So those are the 2 events. So you're going to go first. What is the probability, bless you, don't worry about reducing fractions. What's the probability the first person would grab a purple marble out of that jar? What do you think? Say that one more time. How many purple marbles do we have, though? Did you reduce it for me? Is that what you did? How many? So we got 8 purple marbles, right? 30 in the jar. Does that make sense? Like, okay, so we would have 8 possible marbles that would fit the purple requirement out of the 30 that are in the jar. Does that make sense? Okay, now I'm going to assume that I picked the purple marble out of the jar. What is then the probability? So we got 8 purple, 10 yellow, 12 pink. What is the probability then your friend goes after you and they grab a yellow one? Yes. Okay, so 10, because you're assuming you grabbed one of the purple ones, but if you held yours out, now there's only 29 marbles left in the jar, so the bottom of that fraction would be different. And then we would just multiply these 2 guys together. So again, I'm just using my calculator here. So you don't have to reduce the fraction if you don't want to until the end. You can just multiply these guys with your calculator here. Oh, sorry, there's a glare. What do we got? All right, so this is 0.0, let's say 92 to 3 decimal places, or if I want to do that as a fraction, that's reduced 8/87. All right, now, this is a little interesting. What's the probability both people would choose a purple? So the probability you would choose a marble if you go first is the same, right? 8 out of 30. Now, the probability of the second event, the other person now also chooses a purple marble, assuming that you grabbed a purple marble out when you took your turn. What would that be? There you go, very good, 7/29. Because you're assuming you grabbed one of the purple marbles, so now there would only be 7 of them left for your friend. All right, so, oh, there's a glare today. All right, 8 out of 30, multiply that by 7 out of 29. All right, so this guy's like 0.064 to 3 decimal places. If you want to do a fraction, we're going to do 28/435. Is anybody having a question? Okay. Now, on these, it's not going to tell you straight up if it's independent or dependent, so we're going to have to figure that out from reading the problem. And my first beautiful problem here is like a little wheel of fortune spinner. All right, so it says you're going to spin the wheel twice. This is not the exact wheel of fortune wheel, but similar to that. Okay, probability your first spin is worth more than $500. So just literally to save us some time, and this is kind of tiny, but everywhere you see a little A, that is a spot on the wheel that's monetary value is more than $500. So I just went around the little thing and identified those. So there are, let's see, there's 8 of them. Okay, so what's the probability I land on one of those on my first attempt, and then on my second attempt, I land on the bankrupt, which that's what I put the little B next to the 2 spaces that say bankrupt. And it says there are 24 total spaces on the wheel here. They're all evenly spaced and everything. So how would you calculate this? Would you call this independent or dependent? What do you think? Because? Yeah, you don't like pull something off the wheel or anything like that. You could argue perhaps maybe like where the wheel starts and how you're spinning it could affect it, but technically it's independent in this case because we're not removing anything from the wheel. So all events should be equally likely since they're the same space there. Okay, so the probability I get one of these guys that's over $500, there's 8 of those out of the 24 spaces. We're just going to then spin again, so all the events are equally likely. That's independent, so there's 2 bankrupt spaces for that second one. And I know, again, you can reduce both of those fractions, but if you just want to do this on your calculator just to save some time, if you want to practice reducing fractions and multiplying them, you are more than welcome to do that as well. So I'm just going to multiply these guys together, and we're going to get 0.028, and then I'm just going to convert that to a fraction real quick. So this would be 1/36 if you have to write it as a fraction. Anybody have a question? Okay. Now I'm finding people don't know a ton about decks of cards, so we might have to talk about this one for a second. It says you randomly select 2 cards from a standard 52 card deck. Okay, what's the probability the first card is not a face card? So not a face card would be like ace, 2, 3, 4, up to 9. A face card is a king, a queen, or a jack. And says, so the probability I get a number card on my first draw and a face card on my second draw. Now there's 2 kind of questions about this. This says you replace the first card before you take the second, and then part B says you don't replace the first card. If I put the first card I draw back, does that make it dependent or independent? If I put the first card back, this makes it independent because then you would have all the cards again. If I hold the card out, on the second example here, if I hold the card out, then you're changing the number of cards you're picking from, so then that would be dependent. All right, so does anybody know how many including aces, how many number cards there are in a deck of cards? 40, yeah. So you've got ace, 2, 3, up to 9 in 4 suits. There are 10 in each suit, so it would be 40. Okay, does anybody know how many face cards are in a deck of cards? So king, queen, and jack. 12, because you have 3 and you have 4 suits. So this would be 12. And it would still be 52, because whatever card you draw first, you're going to put it back. So the bottom number should be the same if you have independent events. So we have 40 out of 52, multiply that by 12 out of 52. And so let's go 0.176 to 3 decimal places as a fraction. That is 30 over 169. So a little bit more than 17% chance that that would happen. Okay, now if I hold the first card out, so this would be the same. There are 40 cards that are not face cards, so number cards. Now, I'm assuming that I drew a number card, so all the face cards should still be in the deck. So what would the probability of that second piece be that I draw a face card? Yes, so this would still be 12. What would change would be the 51, because you're assuming you drew a number card. All right, so we're going to do 40 out of 52, and then we're going to multiply that by 12 out of 51. So this is just a little bit higher than the last one, 0.181 to 3 decimal places. And as a lovely fraction, this would be 40 over 221. Okay, does anybody have a question? All right, now we are going to move into or statements here in a second. Now, this little vocab term, I'm going to give you kind of some examples underneath to hopefully explain this a little bit. So, 2 events are considered what we call mutually exclusive if they can't or cannot happen at the same time. So 2 events, they call them mutually exclusive if there's no possible way these 2 things could happen at the same time. Okay, so just some examples. So this says if I roll dice, I cannot roll a 2 and a 3 at the same time. It's one or the other. So these are little examples, actually, these are mutually exclusive on this side. Now, let's say you go to the pet store. You can't choose a dog and a cat at the same time. Let's say you only want to pick one animal. Let me rephrase that. So you want to pick one animal and can't pick a dog and a cat at the same time, just one or the other. If I drew a card, you can't choose a heart and a diamond at the same time. They're different suits. So all these events would be mutually exclusive. Now, just to kind of give you like a comparison, these are not mutually exclusive. So all these events can happen at the same time. So these are not mutually exclusive. I can roll a 2 and an even number at the same time, right? Because 2 is an even number. So if that first thing kind of falls into a category with the second thing they say. I could go to the pet store and pick a dog and a poodle at the same time because a poodle is a dog. So it's like they're the same, they would fall into the same category. They're not 2 separate things. If I'm grabbing cards, I could draw a heart and an ace at the same time if I pick the ace of hearts. So those are possible to happen at the same time. Now, just to kind of make a distinction, sometimes people think mutually exclusive means independent. They're totally different things. So it says, are mutually exclusive events the same as independent? I would say no here. Independent can happen at the same time. Independent events can happen at the same time. Like I could roll a die and flip a coin. Those 2 things can happen at the same time. They're separate, so they're not mutually exclusive. Okay, now this is going to lead us into the probability of A or B. So if you see something like this, if you see the or, I want you to think, okay, we're going to add these probabilities together. So and you're going to multiply or you're going to add. So in general, to do the probability of A or B, and let's say that they, okay, so in general, This is going to mean, let me say not mutually exclusive, because there's a little separate formula for that. If they're not mutually exclusive, there might be some kind of overlap when you calculate this probability. So this is the probability of A plus the probability of B minus, we write it like this, probability of A and B. And what I mean by that, this would, and we're going to do some examples, so I think this will make some more sense. This would be any kind of overlap between the two. That would be the part that these two things could happen at the same time. Like I can roll a 2 and an even because those both fall into the same category. If the events are mutually exclusive, if they cannot happen at the same time, there will be no overlap to their probability. So this will just be probability of A plus probability of B. There's no overlap that you would have to subtract out. So we're going to do a couple examples here. Okay, so my first example, this says 30% of the U.S. population is under 20. So like 1918 on down. 17% of the population is over 60, so like 61, 62 on up. Okay, what's the probability a person chosen at random, just from the entire United States, is under 20 or over 60? So the first thing I got to ask you, can my age be less than 20 and more than 60 at the same time? No. Okay, so these are straight up, there's no overlap here. These are mutually exclusive, so we should just be able to add these probabilities together. And remember, probability falls between 0 and 1 or 0% and 100%. They just in this problem gave you the probabilities as a percentage. So 30% chance the person is under 20 plus 17% chance the person is over 60. You literally just add these together. So if I picked somebody at random from the entire United States, probability that they're under 20 or over 60 would be 47%. Okay, now, does anybody have a question at the moment? Okay, let me scooch this up. Now, see if you can think about this, whether these can happen at the same time. Okay, this says probability of an even or less than 4 if we just roll like a normal die, or sometimes they call it a number cube. So can I be even and less than, and less than 4? Do both of those things happen? Okay, so these guys are not mutually exclusive. So there's going to be some kind of overlap here. So here's what I usually do. If you want to do it like this, it makes it maybe a little bit easier than trying to use that formula. So even numbers, if you roll a die, right, would be 2, 4, 6. Those are all the even numbers you could roll if you rolled dice. Now, a number less than 4, would 4 be included in that group? Just says less than, not less than or equal to. So numbers less than 4 would be 1, 2, and 3. Okay, now, you could just count these all up. That would be 6 options and subtract the overlap. So one way I could do this, I could say, okay, right here there's 3 over 6, plus right here there's another 3 over 6. And then what we would have to be mindful of is we'd have to subtract off any overlap, which if you guys notice, 2 was in both of these categories, so I counted that twice. So here, the first one, this would be the probability of A, this would be probability of B, and then I have to subtract the overlap, which would be that 1 out of 6 that I counted twice, because I counted the 2 in both categories. And if you guys add that up, we're going to end up with 5 over 6 as a fraction there. Okay, now, I don't normally use the formula, so let me show you how I do it with the second one. So probability I'm odd is 1, 3, 5. Probability I'm prime is 1, 2, 3, and 5 on a die. Okay, here's how I do this. There are 6 possible things you could get when you roll dice. I just go through the list and I identify all the numbers that are different. So like 1, 3, 5, I already used 1, I didn't use a 2, I already used a 3, I already used a 5. So I just add up what I have left over, so I don't count the overlap. That's usually what I do when I do these problems. So there's 4 numbers here that are different, and that'll save me the step of writing all those probabilities out and subtracting the overlap. So you can do it that way too if you want, or you can use the formula. It's completely up to you. This one would have a probability of 2/3. All right, is anybody having a question? Okay, last tiny example here. So this, no situation involved in this at all. It gives you 2 probabilities. I just want you to remember. So these are the 2 things we talked about today. So if you have an and statement, you want to think, I'm going to multiply these 2 probabilities together. So it says probability of A is 1/6, probability of B is 2/5. So this should just be probability of A times probability of B. Since they give that information to us, we have no idea what these events are, but we can actually just multiply those 2 probabilities that are given to us together here. You do not need a common denominator to multiply fractions. Just straight across the top, straight across the bottom, and then reduce if you can. So 2/30, 1/15. Now, if you have mutually exclusive events, and anytime you have an or, you want to think that, okay, I'm going to add these probabilities together. If they are mutually exclusive, they don't have any overlap, so you don't have to worry about subtracting anything. So in this case, it says probability of C or D should straight up just be the probability of C plus the probability of D. So and statement we're going to multiply, or statement you're going to add. The one thing that is something you got to remember here is when you add fractions, you do need a common denominator. So of course you could use your calculator if you want, but if you want to do it by hand, I'm just going to simplify this real quick. So 1/2 is the same thing, 4/8 plus 3/8. This should be 7/8. That number should never be bigger than 1. If you're doing a probability, you should never have anything bigger than 1. 7/8 is not bigger than 1, so we're in good shape. And if you're mutually exclusive, you don't have an overlap, so you don't have to worry about subtracting anything. Is anybody having a question?